Hey everybody, in this video we're going to continue our study of parallel lines and perpendicular lines. So I'm going to go back to the first page from the previous section, section 2.2, where we discuss parallel and perpendicular lines. Remember, parallel lines means they never intersect, they never cross each other, like the green lines and the blue lines. And so parallel lines means they have the same slope. Perpendicular lines, they cross each other at a 90-degree angle. And so all of these three lines are parallel. The green lines and the blue line are parallel. The black line is perpendicular to all of those. And so perpendicular lines means that there is a 90-degree rotation, which means the x and the y switch places. So the slope, instead of being the rise over the run, becomes the run over the rise. So they switch, so it becomes a reciprocal. So I did a little tiny review on reciprocals. The reciprocal of 1/3 is 3 over 1. Reciprocal of 2/5 is 5 over 2. So you flip it. Our slope here was 2 over 1, so the perpendicular slope is the reciprocal. So it'll be 1 over 2. So you flip it. So, back to talking about parallel and perpendicular lines. So something that you might get are determine whether the following lines are parallel, perpendicular, or neither. So if I have x minus 3y equals 4 and y equals 1 minus 3x, are the lines parallel, perpendicular, or neither? So remember, parallel means they'll never intersect. So if you have two parallel lines, they'll never intersect, so they'll look something like that. Their slopes are the same, so they're never going to deviate from having that same way of increase, that rate of increase. Perpendicular lines means that they will intersect, but when they intersect, they'll intersect at right angles. So when they meet, they'll have a right angle as they meet. Neither, it just means they're two lines that are neither parallel nor perpendicular. So neither could look like any two lines that intersect. So you could have that one and then something like that. So they intersect, but it's not a right angle. And there's lots of different ways the lines could intersect. If they happen to intersect at a right angle, that's when we call them perpendicular. So we talked about parallel lines have the same slope. Perpendicular lines have the slopes. One way to say it and capture the reciprocal part is and one other thing I guess I didn't mention in the previous one is that, and some of you probably already noticed that as these lines are increasing, right, the parallel lines, this one is not increasing, this one is decreasing. So the perpendicular slope is actually negative. So for perpendicular lines, they cross at a 90-degree angle. The slope of a perpendicular line is the negative reciprocal. Oops, I forgot to say that last time. So perpendicular lines have slopes that are negative reciprocals. Of each other. So for example, if one line has slope 2/3, a perpendicular line will have slope negative 3 over 2. And then neither will have, the slopes are not the same and they're not negative reciprocals of one another. So that's a neither. So back to this example. So essentially we want to see, are the slopes the same or the negative reciprocals of one another. So let's call this line A and that one line B. So in order to see their slopes, I'm going to want to put them in y equals mx plus b form. So put the lines in y equals mx plus b form. So for line A, I have x minus 3y equals 4. I'm going to solve for y. So I'm going to have subtract x from both sides. So I have minus 3y equals negative x plus 4. And now divide by minus 3, both sides. When I divide both sides, that means I can divide each thing by minus 3. So here I have y equals negative divided by negative is positive, so I get x over 3 minus 4 over 3. Right, positive divided by negative is negative. So this looks like y equals 1/3 x. We can separate the fraction from the x, minus 4/3. So I really just care about the slope. So the slope here is positive 1/3. If they're parallel, I want line B to also have slope of positive 1/3. If they're perpendicular, what would you want this slope to be? The slope for line B. We don't want it to be the reciprocal and negative, so negative 3. Let's look at line B. Y equals 1 minus 3x. So this actually is already in y equals mx plus b. It's just that the x and the b are flipped. So let's say y equals, just rearrange it, minus 3x plus 1. So let's look at the slope here. M is negative 3. So they are, in fact, opposite reciprocals. Right, because you can think of this as 3 over 1. 3 over 1 is the reciprocal of 1/3, and that's negative and that's positive. So they're opposite sign and they're reciprocals. So the lines are perpendicular. So over here, the lines are perpendicular. Okay. Another example that I have for you is finding the equation of a line when you're told something about it. So let's try. Find the equation of a line find an equation of the line containing the point. There are many points in the line, so depending on the point that you use, that's what the equation will look like. So one line can be interpreted in many different ways, many different equations depending on the point. So that's why I changed that to find an equation of the line containing the point negative 5, 2 that is perpendicular. Perpendicular to the line y equals 2x minus 1. So I want to find an equation, and as we did before in the previous section, to find the equation of a line, we use either y equals mx plus b or y minus y1 equals mx minus x1. I feel more comfortable using this one, so I'm going to use this one. If you use that one, just check your answer at the end that they should be the same. So to find the equation of any line, we need the slope and a point. I have a point, I need the slope. So let me say that here, we need the slope and a point. So we have the point. The point is negative 5, 2. And how do we find the slope? Right? We don't have it, but I do know that our line is perpendicular to this other line. So let's look at what 2x minus 1 looks like. So it has slope 2 and y-intercept 0, -1. So I'm going to go to -1. The slope is 2, so I'm going to go up 2 and over to the right 1. And this is y equals 2x minus 1. Now what we want to find, our line passes through the point -5, 2. So where is that? 1, 2, 3, 4. -5, 2. So it passes through this point, but it's perpendicular to that line. So it has to go something like this and create that nice right angle. So this is the one that I want to find the equation of. Y equals mx plus b. Right, but we know since the slope of the blue one is 2, my line, the perpendicular line, the slope is going to be, notice that that's positive, so this one should be negative. So negative, and the x and the y switch, the rise and the run switch. So it'll be negative. This is 2 over 1, so this will be -1 over 2. So now I have the slope. So back to my equation. So I can use my perpendicular slope is -1/2, and I can use the point -5, 2 into y minus y1 equals mx minus x1. So I'm going to have y minus 2, right? This is my y1 and that's my x1, equals the slope -1/2 times x minus a minus 5. That's my x value. So I have y minus 2 equals -1/2, really x plus 5, and distribute the -1/2. So -1/2 x minus 5/2. Right, put a 1 there if you need, so do numerator times numerator, denominator times denominator. And now add 2 to both sides. So here it goes away. I'm going to have y equals -1/2 x minus 5/2 plus 2. I can think of that as 2 over 1 and get a common denominator. Common denominator is 2, so multiply top and bottom by 2. And I'm going to backtrack here. So it's going to be y equals -1/2 x, and -5/2 plus this guy becomes 4/2, and to check it, 4 divided by 2 is 2, so we're good. So -5 plus 4 is -1, so it'll be -1/2. So that will be the equation of the line. For my perpendicular line. So that's that one. So the equation of the green line is, well, and clearly I didn't draw it to scale because the y-intercept is -1/2, so it should be over here somewhere. But without knowing it, right, I only knew it went by that point, so I didn't know the slope yet, I didn't know all kinds of stuff. So now that I know the slope and I know the y-intercept, I could draw it accurately to what it looks like.